In the late 1960s, as American railroads fought for survival against highways and jet travel, Union Pacific chose defiance over retreat. Two engines with 8 axles and unmatched force. This was the DDA40X Centennial, the largest diesel locomotive ever built, designed not just to move freight, but to announce dominance. By the late 1960s, American railroads were under siege. Highways sliced across the country, promising speed and flexibility. Jet aircraft shrank continents, turning days of travel into hours. Passenger trains bled relevance, and rail companies watched their dominance slip away, mile by mile. But freight was a different story. Heavy, endless, and essential, it still depended on steel rails. And no railroad felt that pressure more than Union Pacific. Its territory stretched across brutal distances, scorching deserts, punishing mountain grades, and thousands of uninterrupted miles where failure wasn't an option. So how could they survive? Should they scatter the power across long strings of smaller locomotives? Or concentrate it with fewer units, more muscle, and more authority? Union Pacific believed the future didn't belong to subtlety. It belonged to dominance. This was the dawn of the high horsepower diesel era, and railroads weren't just competing economically anymore. They were competing symbolically. The size, power, and presence all mattered. Union Pacific didn't want a locomotive that blended in. It wanted one that commanded the horizon. And the answer they chose wasn't efficiency alone. It was something far more American. If railroads were going to survive, they needed more than efficiency. They needed brute force. In 1969, the nation celebrated the 100th anniversary of the completion of the Transcontinental Railroad, the Golden Spike Ceremony at Promontory Summit, Utah. Union Pacific wanted a living symbol of this milestone. The first unit, number 6,900, was rushed to participate in the May 10, 1969 Golden Spike Centennial ceremonies in Utah. The name Centennial was chosen deliberately. This wasn't only branding, it was also an identity. A locomotive meant to carry history on steel wheels while still solving a very modern problem. But Union Pacific wasn't interested in celebration without consequence. The real question was far more dangerous. What if one locomotive could replace several? And what if power didn't need to be spread across multiple units, but concentrated into one overwhelming force? To answer that, Union Pacific partnered with EMD, giving them a directive that ignored comfort and convention. Push the limits, build bigger, build bolder, do not play safe. Skepticism followed immediately because bigger meant heavier, and heavier meant risk. Union Pacific accepted the risk without hesitation. This wasn't a locomotive meant to blend into the fleet. It was meant to stand above it, visually, mechanically, and symbolically. The Centennial wasn't built to celebrate the past, it was built to dominate the horizon. On paper, the Centennial already sounded excessive. Its designation alone, DDA40X, hinted at something unprecedented. The D stood for 4 powered axles per truck, and with a DD configuration, the locomotive rode on 8 driven axles. This wasn't refinement, it was the concentration of force. Then came the numbers. At 98 feet long, the Centennial stretched longer than many city buses placed end to end. It weighed over 545,000 pounds, pressing 500,000 pounds of steel onto the rails. Power came from 2 EMD 645E3A diesel engines, working in tandem to produce an astonishing 6,600 horsepower, more than any diesel locomotive before it. And yet, despite its scale, it was operated from a single cab by a single crew. But building the largest diesel locomotive ever created raised a brutal engineering question. How do you keep something this massive alive? Twin engines meant twin heat sources. Extreme horsepower demanded relentless cooling. Fuel consumption climbed into unfamiliar territory. The Centennial couldn't be treated like a normal locomotive. It threatened to overwhelm the very systems designed to sustain it. So could raw size be controlled, or would it collapse under its own weight? The answer came in steel and airflow. The Centennial was built with enormous radiators, sprawling across its elongated body, designed to dump heat as aggressively as the engines produced it. Every panel, every vent, every angle served function over form. Elegance was irrelevant. Survival was everything. It burned fuel heavily, demanded respect from maintenance crews, and towered over rail yards like a moving industrial structure, rectangular, intimidating, and unapologetic. This was not a locomotive shaped by aesthetics. It was shaped by forces of torque, heat, mass, and momentum. This wasn't graceful, it was geological. When the Centennial entered service, it didn't just set a record, it shattered expectations. At 6,600 horsepower, it instantly became the most powerful diesel locomotive in the world. In practical terms, a single DDA40X could replace several standard locomotives, consolidating power into one overwhelming unit. That power wasn't theoretical. The Centennial was built to haul heavy freight, long intermodal trains, bulk commodities, and massive consists that demanded both muscle and endurance. 8 traction motors delivered relentless torque to the rails, while its twin engines allowed it to maintain sustained high speeds across distances that would exhaust lesser machines. This was power designed for the West. But numbers alone don't move trains. Could a machine this large actually perform where it mattered? Across deserts, mountains, and endless open territory? Could it translate raw horsepower into real-world dominance? Out on the rails of Wyoming, Utah, and Nevada, the answer became unmistakable. Crews watched in awe as the Centennial pulled with authority, its mass anchoring it to the track, its power refusing to fade. Engineers felt both intimidation and pride behind the controls of a machine unlike anything else in service. Railfans gathered just to see it pass. The public didn't need specifications to understand what they were witnessing. When the Centennial moved, even the ground noticed. Between 1969 and 1971, Union Pacific placed 47 Centennial locomotives into service. They were never sold to other railroads, never exported, and never shared. The DDA40X was a Union Pacific-only experiment, assigned to long, flat, high-speed freight corridors where sheer power mattered more than flexibility. But building the most powerful diesel locomotive in history raised an unavoidable question. Could a machine this extreme survive the realities of daily railroad operations? On the open rails, the Centennial delivered exactly what it promised. Its immense power meant fewer locomotives were needed per train, simplifying consists and reducing crew coordination. On long runs, it pulled relentlessly, eating up miles with confidence and authority. But power came at a price. The Centennial's twin-engine design doubled everything: heat, wear, maintenance demands, and failure points. When one engine had an issue, the entire locomotive suffered. Downtime wasn't inconvenient, it was expensive. Rail yards struggled to service its 98-foot length, and not every facility was equipped to handle something so massive. Crews respected the Centennial deeply, but they also feared it. When it ran smoothly, it felt unstoppable. When it didn't, it became a logistical nightmare. Owning a Centennial wasn't like owning a standard locomotive, it was like owning a supercar. Breathtaking when it worked, punishing when it didn't. By the early 1970s, the world around the Centennial began to change. Fuel prices climbed, economics tightened, and railroads were forced to rethink what power really meant. The question was no longer whether the Centennial was impressive, it was whether it still made sense. Could the largest diesel locomotive ever built survive in an era that suddenly valued efficiency over excess? The oil crisis of the 1970s delivered the answer brutally. Fuel efficiency became critical, and the Centennial's appetite for diesel turned from tolerable to costly. At the same time, advances in multiple unit control allowed railroads to link smaller locomotives together seamlessly, creating flexible modular power that could be adjusted train by train. Compared to that adaptability, the Centennial felt rigid. Its maintenance costs soared, and reliability issues compounded as both engines aged together. When it failed big. When it needed service, it demanded time, space, and money. Railroads no longer wanted monuments. They wanted tools. Gradually, the Centennial shifted from flagship to liability, a machine born for dominance, now trapped by changing priorities. The industry was moving forward, and it wasn't moving as one giant. It was moving in pieces. The age of giants was giving way to the age of efficiency. By the early 1980s, the Centennial's era was quietly drawing to a close. Railroads had moved on, and the giants that once ruled the Western rails were slowly sidelined. So what happens when the most powerful diesel ever built is no longer needed? How does a legend leave the rails? Retirement came gradually, not with fanfare, but with silence. One by one, Centennials were pulled from service, their massive frames parked in yards where they once thundered through at speed. A few were scrapped, dismantled for parts, their engines silenced forever. 13 of the 47 were spared, preserved not for usefulness, but for what they represented. Proof that railroads once dared to ask, how big could we go? For Railfans, the loss was deeply emotional. These weren't just locomotives, they were statements. Seeing them cut apart felt like watching a chapter of industrial ambition close for good. Steel that once shook the ground now sat still, and engines built to dominate waited quietly. Even legends must eventually shut down. Number 6936 remains operational today, returned to service in 2023 by the railroading heritage of Midwest America after Union Pacific donated it in 2022. Decades after its retirement, the DDA40X still holds the record as the largest diesel locomotive ever built. Its size and power remain unmatched, a testament to a time when ambition outweighed practicality. But why does a machine that never dominated the rails still capture hearts and imaginations? Because the Centennial represents more than raw horsepower. It embodied the maximum power philosophy, inspiring future high horsepower locomotives and reminding the world that railroads could be daring. Railfans preserve its legend, traveling miles to see the few remaining units, now pilgrimage sites for those who revere engineering audacity. It wasn't built to last forever, nor was it built to be practical. It was built to prove what was possible. The story of the DDA40X Centennial is a journey through crisis, ambition, and reality. It emerged during an era when American railroads faced existential threats, at a time when efficiency often outweighed spectacle. And yet, Union Pacific chose audacity over caution, daring to build the largest diesel locomotive the world had ever seen. Could such a colossal experiment succeed? Could a machine this enormous prove its worth in daily service? Or was it destined to be remembered only as a curiosity? The Centennial wasn't a failure. It was a statement, a rolling testament to what engineering courage, vision, and sheer willpower could achieve. It hauled freight, but it also carried the ego, ambition, and courage of an entire era of American railroading. But what do you think? And which legendary machine should we break down next? If you enjoyed this, make sure to check out our video on the Russian locomotive Cherepanov.